Hi, my name is Eldridge from Sustainable Operations Management and Design Team in ARTC. Today, I'll be presenting to you E2MAS platform that focuses on energy, resource, monitoring and analytics. E2MAS is short for Energy Efficiency Monitoring and Analytics System. It is part of the 4 key modular platform for energy and resource analytics. E2MAS is focused on improving energy efficiencies for companies that focuses on equipment, processes or even production line to reduce overall energy consumption and losses. There are 3 main key features for the E2MAS platform. First, it comes with an interactive dashboard that shows real-time visibility of all the machines in the shop floor. By having real-time visibility of energy consumption of the machines in the shop floor, we will be able to identify the highest energy-consuming equipment to look into and improve our energy consumption. The second feature of E2MAS is the suite of data analytics module that is able to identify energy hotspots and opportunities for energy improvements. In addition, it is able to identify process anomalies through energy efficiencies and notify users whenever there is such incidents for them to look into. The third feature is the ability to generate reports for internal stakeholders to enable data-driven decision-making, as well as external stakeholders for energy and sustainability audits. Like any other energy management systems, E2MAS requires data to be collected from equipment. Data such as energy consumption, production output, and operating factors has to be collected in real time from existing meters or systems and then stored into a database server where the E2MAS platform will tap on this data to show it on the interactive dashboard. In the event where companies is unable to fulfill the E2MAS requirements, ARTC can come in with preferred system integrators, either from companies or from ARTC, to help them bridge the gaps to enable full functionality of the E2MAS platform. As mentioned earlier, E2MAS comes with several analytical modules to provide value add for companies. The first module is a real-time efficiency analysis, where it looks into energy efficiencies for production parameters such as produce unit activities, or in a case where we want to compare different plants, it will be in terms of revenue dollar. The second module is a real-time benchmarking analytical module, where it identifies historical best energy efficiency of a particular equipment. By having this information, you can compare the energy efficiency from the current state to historical best and identify if there's any anomalies or hotspots in the current process. So the third module is the online causal analysis. In an event where anomalies are detected, this analytical module will be able to identify causal factors or operating parameters for customers to fine-tune on their machine or processes to achieve better energy efficiencies. Let me give you an example on how E2MAS can help in terms of a particular production process for the company. In this case, we'll be going through a heating process to provide an oxide layer on silicon wafers, and this is very common in the semiconductor industry. As you can see in the green box is the process flow in terms of how operating parameters such as temperature, process time, ramp up and ramp down rate will affect the oxide thickness being produced on the part itself. And of course, with the operating factors, there will be electricity consumption. E2MAS will look into historical data and identify the optimal parameters to achieve the highest energy efficiency. And making use of the online causal analysis module, it is also able to identify key operating factors to allow customers to know what are the parameters required to achieve the highest energy efficiency. On the bottom right-hand corner of the slide, you can see a table of the current operating parameters as well as the optimal parameter settings to obtain highest energy efficiency. As you can see, both parameters are able to achieve the same outcome of 1 micron oxide thickness. However, energy consumption is 30% lesser in the optimal condition. If we study deeper through the parameter settings, even though we observe that temperature is higher at 1150 degrees Celsius for optimal settings compared to 1000 degrees Celsius for current, which we expect more energy consumption to happen, the process time is 60% lesser for the optimal condition. Through this information, we are able to conclude that having higher temperature setting will not only reduce process time, but 30% reduction in energy consumption. So in real time, E2MAS will be able to provide such information through our analytical modules, and in this case study, we will be able to achieve energy consumption reduction, as well as increased productivity due to lower process time for the heating process. We have worked with a particular company called LHT. LHT produces pellets that is used in industry for packaging. As you can see from the graph in the middle, you can see that there are 4 different stages of energy consumption. The first 2 from the left indicates the production volume as well as energy consumption in the morning, and the remaining 2 on the right indicates the energy production and energy consumption for the afternoon. From what we observe, that energy consumption is actually lower in the morning than in the afternoon. We have reported this to LHT, and they have further investigated in terms of what are the key parameters that are affecting this lower energy consumption in the morning. Using this information, they are able to overall improve their energy consumption in the later part of the day, in the afternoon, to save 20% of energy consumption, and this results in also 20% of reduction of carbon emission. As most of the processes for reporting is completely manual, by using this E2MAS platform, they are able to convert energy reports into completely digital process, and as reports are also stored within the E2MAS platform, they are easily accessible to make better decisions for energy savings. Now, I will show you a live demonstration on how E2MAS platform is able to provide value for equipment like a 3D printer. We have connected a power meter to a 3D printer to obtain the energy data, and also tapped on the process parameters such as temperature, layers of print, and using this information to display on the screen itself. Let me bring your focus to the E2MAS dashboard. As you can see, it gives several kind of indicators for the 3D printer process. First, it will show the energy consumption in kilowatt hours, the specific energy consumption, meaning the energy consumption per unit produced, the cost of the energy produced, as well as the amount of carbon footprint that is generated through this process. Here you can see there's the energy flow, the total energy consumption as shown over here, and the value added and non-value added values. Value added values represents the amount of energy that is consumed to actually produce a part, while non-value added are energy consumed for non-essential parts such as when the machine is in idle. In this area, you will be able to see the anomalies that has been detected from the 3D printing process and the respective efficiencies of the energy consumption of the 3D processes during these particular time frames. If we go deeper into investigate what are the reasons behind these low energy efficiencies, we can see that relative to past performances at the highest energy efficiencies is only at 84%. And if we look at the key parameters that has been shown over here, we can compare between the historical best as well as the current state. So the reason behind the lower energy efficiencies can come in 2 reasons. First, we observe that the printing time is actually 7 minutes lower for the optimal condition compared to the latest print. And if you look deeper into the process parameters itself, the number of printed layers has actually increased by 3, while the temperature has also increased by 4 degrees Celsius. As a result, even though we are printing the same parts, the machine is actually printing more layers and using more energy to increase the temperature to print these layers. With this information from the E2MAS dashboard, companies will be able to identify anomalies in real time and look at what process parameters that has been applied in the past to have the ideal energy consumption. With this, they can apply these old parameters into their current production to reduce energy consumption. But of course, this has to be discussed with the process owners of, for example, this 3D printing machine to enable a good interaction and needs to save energy. So in conclusion, E2MAS is a monitoring and analytics platform for key production processes in the shop floor. With this real-time dashboard and information that can be identified by users, companies can make full use of data to make good decisions to improve their energy consumption and increase their energy efficiencies of their production processes.